All right, hi guys. We are going to start the very last lesson of our module, and we are already on lesson 10, which is really hard to believe. So the last lesson is proportional versus non-proportional relationships. And what that really means is I want you guys to understand the constant of proportionality, it's called. So it's the ratio of y to x when x and y form a proportional relationship. So if you can look over here, there is a coordinate plane with the 4 quadrants. And we are going to use this when we're going to be asking ourselves if x and y form a proportional relationship to one another. And if you're confused about what that means right now, I'm going to show you in this example, okay? So the first thing we have to do is go back to number 1, and it shows right here a ratio, okay? And it's 36:4. And I can't leave this ratio like this. I have to write this ratio in simplest form. And the way I'm going to do that is I'm going to divide the numerator and the denominator by their greatest common factor. So the greatest common factor between 36 and 4, all right, is 4. Because 36 can be divided by 4. It can also be divided by 4 on the bottom, okay? Which then gives us 9/1, because 36 divided by 4 is 9, and 4 divided by 4 is 1, okay? And then I could take that further and just say that that's really 9, because 9/1 is just 9, okay? All right, so I know you guys are doing a really great job with that, and I know you know how to reduce fractions, really, because that's really all a ratio is, reducing fractions or finding a ratio in simplest form. So let's go over here to number 2. It says, well, what is the x-coordinate for point A? Okay, so A right here is an ordered pair. Let me see if I can zoom in a little bit more with my phone here. So my ordered pair is 4/2, all right? And just to give you a little recap here, my ordered pair, what comes first when I have an ordered pair? X goes first, then Y. X is horizontal, Y is vertical. Okay? You can kind of think back to when we played Battleship. X, Y. So if we graphed this ordered pair, I would say 4, and then Y would be up 2, because both of my ordered pairs are both positive, okay? So we're in the positive quadrant. We're in quadrant number 1. All right, so you know how to do this. You know how to graph an ordered pair, so we're halfway there. So we're going to go to number 3. All right, let's zoom out here. All right. Okay. So for number 3, let's look at this table. So this table has all of my x values, and then this table has all of my y values. All right. So I have to determine whether or not there's a relationship between the variables x and y. Okay. So what we're going to do is we are going to first write these ordered pairs as ratios, okay? So right here it says the ratio of y to x. All right, well that's cool. Y comes first, x comes second. So for this first ratio, I'm going to look right here, or I'm going to circle it for you. Y to x. So that means my y goes first, goes up on the top. Y to x. Perfect. All right, let's go to the next one. y to x for the next one. 15 to 5. All right, 15 to 5. 24 to 8. 33 to 11. And 45 to 15. Well, those are some pretty big ratios, and they want us to write these ratios in simplest form, all right? So the simplest form of the ratio 6 to 2. Well, I have to figure out what my greatest common factor is between 6 and 2. So let me get my notebook here, and you might have to do some work over here on the side. All right, so if I said, well, 6 to 2, well, I know that the greatest common factor between 6 and 2 is 2, because 2 can go into 2, and it can also go into 6, which will then turn into 3 to 1. Okay, so my ratio in simplest form for 6 to 2 is 3 to 1. And I'm going to do that for every single one of these ratios up here. So my next ratio is 15 to 5. Well, I know my greatest common factor for this ratio is 5. 5 can go into 5 once, and 5 can go into 15 3 times. Oh, look at that. They are the same. I wonder if they have a relationship. All right, well, let's keep going and find out. So 24 to 8, I know that my greatest common factor is 8, because 8 can go into 8 once, and it can also go into 24 3 times. What? Okay, we're gonna keep going here. And 33 11s, well, I know my greatest common factor here is 11. 11 can go into 11 once, and 33 divided by 11 is 3. Oh my goodness, there is another 3 to 1. And then our very final 45 to 15. I know that my greatest common factor for this one is 15. And it is 3 to 1 again. We have a winner. So, if you can look, all of these ratios can be simplified into these ratios, 3 to 1. All right, so do all of these ratios have a proportional relationship, or do they form a proportional relationship? And the answer is going to be yes, because they're all the same. All right, so they do. And what is the same about all of these relationships? Okay, 3, right? Y equals 3, okay? So, they do have a proportional relationship. The next thing I'm going to show you is how to take this information and actually place it on the coordinate plane to show that it has a proportional relationship. So, let's go to build the